Hi, I'm Dustin Langell. I'm a principal and higher education practice leader with Loyola Engineering, and I'm going to talk about LUREC. It's about 100 acres of wetlands, woodlands, prairies, and savannas, and it serves as a place for Loyola to host retreats for different users, as well as serves in their mission to study and practice ecology and other sustainability efforts. We've been working at LUREC for going on 13 years now. It's one of my first projects with Loyola University personally, and from the beginning, we were tasked with putting together a master plan to bring the campus to net zero over a 10 to 15 year timeline, and we're deep into phases of construction trying to implement that. Where we stand today is the campus, about half the campus has been converted to geothermal and switched from old inefficient gas boiler heating to green geothermal cooling and heating. As part of that, we added cooling to the building. Originally it wasn't cooled, but we're doing that in a sustainable and efficient way while replacing aged equipment. This is all while the building has been occupied, hosting retreats, conferences, and fulfilling their mission of performing research on ecology. So every phase occurs typically during a summer, and we work through how that will be implemented. Yeah, so the first process for determining the path to net zero for LUREC was to create a master plan. So we went out there, we surveyed the campus, the acreage, met with Loyola University staff and facilities partners, and walked through where we can find good synergies. So as part of that master plan, we evaluated different sources of geothermal, including using one of the ponds that was on site and more traditional vertical drilled boreholes. We also looked at using some of the fields for solar arrays, solar thermal on the roof, upgrading the envelope, and things like that. Part of that process is developing a full energy model of the building, which we've actually updated over 13 years of working there in transition softwares and improved accuracy, and then included utility bills and data validation into that. But as part of the master plan, we identified all these strategies and then evaluated costs and benefit along with phasing. Part of the original goal from Loyola was always to be able to phase this over a long period of time. It doesn't seem that long ago, but 10 years ago, the cost of solar was about 80% more than where it is now. And so knowing that at the time the cost was rapidly dropping, the implementation of any renewables was always the last step. And the first step was greatly improving the energy efficiency of the building through the envelope and the mechanical systems. The master plan really allows us to identify all the options and then weigh them with pros and cons versus what the university's goals are and technology that's available at the time. It's always evolving. So we updated the master plan 2 years ago. After having it been 10 years, technology has changed, costs have changed, and we've learned more about the campus through monitoring utility bills, as well as talking with the people that maintain the equipment and the campus itself. The master plan allows us to set a roadmap for where we're going and set clear targets and timelines for that. Without it, you're kind of taking steps in the dark. So that master plan and its update, live as a working document, but also as a path forward. So there's actually a like running spring at Loyola. So they use a water well for water, but near the water well, there's a spring where water's coming out of the ground, and we at one point measured the flow rate of that spring to help us identify how much groundwater was moving through the ground to estimate the performance of the geothermal field. One of the challenges with the geothermal field, and actually it's a good thing, is the trying to maintain or manage the drilling operation so that it met the ecological mission of the campus. Right, so when you drill, you have a lot of cuttings and fluid that come up, and it was important that those get managed through settling basins so that it didn't end up in the ponds or in the wetlands. Through detailed coordination with the contractors and the university, including the ecology department, we worked through how we were going to implement settling basins and where the boreholes were going to go so that they didn't impact or hurt the life or growth of the trees in the area. The borehole field ended up being located in a field just next to the building, which now is native wildflowers and other plantings. So it's kind of a cool site, relative to your typical geothermal system. So we started this project in 2010 with a master plan, as well as a lab built out in the lower level. So the actual ecology labs that are used today were built out at that time. Today, 13 years in, we've completed with the conversion to geothermal of the older section of campus and the replacement of the equipment there. In the future, the next step for us is converting the relatively newer section of the campus to geothermal and replacing the aged, inefficient electric equipment in that portion of the campus. Challenges associated with that is that will require a little bit more of envelope upgrade, and that includes window replacement, along with replacement of all of the HVAC system and roughly another 20 vertical boreholes. And this section of the campus is where most of their conference spaces are, so from a phasing perspective, we'll have to work around conference planning and construction. Once all of the building is converted to geothermal, the final phase will be to implement a solar PV system to offset the remaining electric usage and convert the building to true net zero. Starting this in 2010, at the time, decarbonization wasn't a buzzword. Obviously now it's a big topic in the news, as well as with a lot of our institutional clients. Going to geothermal and converting to electric for both heating and cooling here, we've actually been on the process of decarbonizing LUREC since 2010, and it's really a proven technology and way of doing that.